in trigonometry one important proof is pending. Okay, one important proof, so we'll do that. Okay, prove geometrically cos x plus y, cos of x plus y equals to cos x cos y minus sin x and sin y. Hence, deduce that cos 2x equals to cos square x minus sin square x. Okay, note this problem. Okay, very important, almost fixed problem. Okay, for your annual exam. Question is mentioned that prove geometrically. Okay, prove geometrically, it means we will make a geometric figure first. With the help of geometry, we will prove it. Okay, so this proof we will do by using unit circle in the xy plane. This is the xy plane. Okay, this is x axis, this is y axis. Then I need a circle. Okay, this is a unit circle whose center at origin 0, 0. So whatever I made a figure, I will write in the language. So I will write let. Okay, let's consider a circle, unit circle, not circle, unit circle. Unit circle means a circle whose radius is 1 unit. Consider a unit circle with center at origin. Okay, center at origin. Okay, center at origin. After that, we will consider 4 points on the circle. 4 points on the circle. So then take 4 points on the circle. Suppose this is P1 first point, this is P2 second point, and this is P3 second point, and this is P4 fourth point. Okay, and you know, when you consider any point on the circle, coordinates of any point on the circle is given by r cos theta comma r sin theta. Coordinate of any point on the circle. Okay, any point on the circle will be of this form, where this r means radius of the circle. Okay, r means radius and theta means angle with the x-axis. Okay, angle with the x-axis. So because our circle is unit circle, so unit circle radius is 1, so here r value 1, it means whatever points in this circle I will assume coordinate will look like this, cos theta comma sin theta, because r is 1, so it will be cos theta comma sin theta. Don't write anything, first you listen only. Cos theta comma sin theta. Okay, then what I did, consider 4 points. Okay, take 4 points on the circle. Okay, as shown. Then we have to join these points with the origin. So I will join all these points with the origin. So let me join this one. Okay, and this. Okay, so I have joined P1, P2, P3, P4, all the points I have joined with the origin. Okay, then but to give the coordinate of P1, P2, P3, P4, I need to consider angle also, then only I can tell the coordinate. So I will say, suppose this P1 point, Okay, this line OP1, it makes angle X with the positive x-axis. Then what is the coordinate of P1 point? So P1 point coordinate will be cos x comma sin x. I told you no, always coordinate on the circle cos theta comma sin theta. Theta is the angle. So if angle of this point, I mean angle of this OP1 with the x-axis small x, it means the coordinate will be cos theta comma sin theta. Now this angle I am considering here to here y. Then can you tell me coordinate of P2 point? Coordinate of P2 point. Okay. Cos x plus y comma sin x plus y. Why x plus y? Because this much angle x, okay, here till here angle x, then here angle y. So we have to consider angle from the x-axis. So from x-axis the OP2 makes x plus y angle. So coordinate of P2 point will be cos x plus y comma sin x plus y. So here P1 coordinate P1 cos x comma sin x, okay, and coordinate of P2 cos x plus y comma sin x plus y comma sin x plus y. Okay. Then for P3 I will take angle minus y. Okay, I will take angle in the clockwise sense. Then angle will be negative. This, okay, arrow, see my arrow. So this is minus y. Then coordinate of P3 point cos minus y, because angle is in the clockwise sense, angle is negative. So cos minus y comma sin minus y. Okay, and you know very well cos minus theta plus cos theta, cos each negative sign inside. So it can also be written as P3 point cos y comma sin y. Okay. Now coordinate of P4 point, P4, this point, this OP4 line, OP4, this is O origin here and this is P4. So OP4, how much angle making with the x-axis? OP4 itself part of x-axis. So any line with itself making 0 degree angle, 0 degree. So coordinate of P4 point will be cos 0 comma sin 0. But cos 0 value is 1 and sin 0 value is 0. So coordinate of P4 will be 1 comma 0. So from here cos 0 comma sin 0, I said cos 0 comma sin 0, and which is same as P4 point, same as 0 comma 1 comma 0. Okay, so this is the construction part over. Still we need to join P3 P1. See, I am joining P3 P1 here, this, and I am joining P2 P4. When we join P3 P1 and P2 P4, then we can see there are two triangles. Okay, two triangles. One triangle is OP2 P4 and one is OP1 P3. So with the help of these two triangles, we will proceed further. Till here note. Okay. Now see, you can see there are two triangles. Triangle P2O P4 and one triangle is P1O P3. Okay, there are two triangles. Okay, so we will use the property so that we will prove that these two triangles are congruent. Congruent triangles, 9th class and 10th class similar triangles. Congruent meaning is what? If two things are congruent, then one thing will cover the other thing perfectly. Okay, perfectly. For example, your page of the copies, all the pages, they are congruent to each other because one page covers the other page perfectly. If you see this OP2, I am talking about P2O4. OP2 is what? Radius of the circle. Also OP1, I mean OP2 radius, OP4 also radius. correct? Now see in the triangle OP1, P1 OP3, OP1 is radius, okay, and OP3 also radius, and all radius of circle always equal, obviously, all circle always radius. It means this side, this side OP1 same as OP4, this side equal, and then OP3 same as this OP2. It means corresponding two sides are equal. Two sides are equal. OP1 equals to OP2 and OP4 equals to OP3. And if you observe, one angle is also equal. Which angle? I am talking about this angle. If you see, this is from here to here, it is y, and this also y, and this is common to both. This is common to both. It means two sides equal and one angle equal. Okay, one angle equal. So you can apply side angle. You can apply side angle side SAS criterion. You can apply SAS criterion. Then you can say the triangle P2O P4 and triangle P1O P3 are congruent triangle. If they are congruent triangle, then all the corresponding sides equal. Okay. So you can write like this: by, I'm not proving here, okay, explain how it is coming. By SAS criterion, okay, criterion, triangle P2O4 congruent to triangle P1O P3. It means all the corresponding sides must be equal. So we can say also this P1 P3 sides must be equals to P2 P4. So we can say, so we can write P1 P3 must be equals to P2 P4. If P1 P3 must be equals to P2 P4, then P1 P3 what? Distance between P1 and P3. And what is P2 P4? Distance between P2 and P4. Now we can apply distance formula. Distance formula. How to get P1 P3 value? P1 coordinate where? This is P1 coordinate. This. Okay. And P3, this is the P3 coordinate. This. So what is the distance formula? How to get distance between 2 points? First coordinate minus second coordinate whole square plus that y coordinate whole square. So can we write like this? This P1 P3 distance means root over its first coordinate cos x, and here first coordinate cos y. It is now, it is minus sin y, okay, sine of minus y minus sin y. So cos x minus cos y whole square, and then its y coordinate and its y coordinate, sin x, okay, minus, and this minus plus sin y whole square. So this is P1 P3 distance formula, root over x1 minus x2 whole square plus y1 minus y2 whole square. Now similarly tell me this P2 P4, about P2 P4. Now see P2 x coordinate, this is x coordinate of P2, and where is P4 x coordinate? 1. So it will be root over cos x plus y minus 1 whole square. Now see y coordinate of P2 this, and y coordinate of P4 this 0. So it will be sin x plus y minus 0 whole square. Okay. Now we have to solve it, and we will get the our proof. We have to solve and we will get our proof. Now do one thing, squaring on both sides, that square will cancel. Do one thing, squaring on both sides. It is plus squaring on both sides. Then square root cancel, and at a time you can open this a minus b whole square. What is a minus b whole square? A square plus b square minus 2ab. So it will be cos square x, square root cancel now because squaring on both sides I have written. So cos square x plus sin square x, cos square x plus sin square and cos square y, cos square y minus 2 cos x cos y. Okay, now plus here, so plus, open this, a plus b whole square. A is sin x, b is sin y, so it will be sin square x. Okay, sin square x plus sin square y and plus 2 sin x sin y. Left hand side is done. Now solve right hand side. Right hand side is square root already over cancelled. Now here it is a minus b whole square. A means cos x plus y, b means 1. So when you open this, you will get cos square x plus y plus 1 square minus 2ab. Minus 2ab means minus 2 into cos x plus y into 1. It will be 2 cos x plus y. This is done. Now come to this. It is 0, so 0, subtracting 0 is, this is useless. Okay, there is no significance of minus 0. So sin x plus y whole square will be sin square x plus y. After that we will apply identities, trigonometric identities. You can see this is cos square x, okay, and this is sin square x. So cos square x plus sin square x is 1. It is 1. Okay, plus now cos square y here and here sin square y, again together 1. Okay, minus 2 cos x cos y and plus 2 sin x sin y equals to, now here same cos square x plus y plus sin square x plus y, this is also 1, this is also 1. Okay, and 1 square is 1, minus 2 cos x plus y. Okay, next, okay, here 1 plus 1 is 2. Okay, 2 minus 2 cos x cos y and plus 2 sin x sin y equals to, here 1 plus 1 2, 2 minus 2 cos of x plus y, then this 2 to cancel, this 2 to cancel, correct, and from left hand side minus 2 we can take common. When minus 2 common, inside is cos x cos y minus sin x sin y, and this side minus 2 cos of x plus y. So next step, minus 2 and minus 2 cancel. So what is remaining? This side we can write first. It implies that cos of x plus y equals to cos x cos y minus sin x and sin y. Okay, this was the proof which we wanted to. Okay, done. So this is proved. Then I have written, hence deduce that cos 2x is cos square x minus sin square x. You observe this quantity. How to get cos 2x? Cos 2x can be written as cos x plus x. So if you put here y equals to x, in this put y equals to x, then you will get cos x plus x equals to cos x minus sin x sin x. So it will be cos 2x equals to cos square x minus sin square x. Okay, so this also proved, and this is formula for cos 2x. Okay, both are note now.